Welcome to today's lesson. Today we are going to look at Form 2 chemistry. That is the first topic under the structure of the atom and the periodic table. In Form 1 we talked about chemistry as the study of structure, composition and properties of matter, and we said matter is anything that has mass and occupies space. And also we said that matter, in terms of composition, it is made up of particles, and one of the examples of these particles is an atom. So we say an atom is the smallest particle, of an element, the smallest particle of an element that can take part in a chemical reaction, that can take part in a chemical process or reaction. These atoms are made up of other smaller particles, which are protons, neutrons and electrons. So we can say atoms are made up of three kinds. They are made up of three kinds of subatomic particles, namely we have protons, we have electrons, we also have neutrons. These three subatomic particles have their own characteristics. Protons are always known to carry positive charges, and because of that we say they are positively charged. Electrons are known to carry negative charges, and because of that we say electrons are negatively charged. And the neutrons are neutral. Neutrons do not have any charge, and therefore we say are neutral. Neutrons are neutral, i.e. they have no charge. i.e. neutrons do not have any charge, and therefore they are said to be neutral. So if we can represent the structure of an atom, we are going to use this circular shape with a small part at the center, which represents the center of an atom, and the center of an atom is known as the nucleus, and the outer part surrounding the nucleus is where we have the energy levels. So this is the energy level region. The outer part surrounding the nucleus, we call it the energy level region, and this energy level region is occupied by electrons, while the central part, called the nucleus, is occupied by protons and neutrons. So in other words, the subatomic particles that occupy the nucleus are the protons and the neutrons, while the subatomic particles that occupy the energy levels are known as the electrons. The number of protons in the nucleus of an atom gives us what we call the atomic number, while the sum number of protons and the neutrons give us the mass number. So if we move down, we can have what we call mass number and atomic number. Mass number and atomic number. So when we talk about atomic number simply represents the number of protons in the nucleus of an atom. Is the number of protons in the nucleus of an atom of an element. Then of course we have the mass number. And then mass number represents all the protons and all the neutrons in an atom, and therefore we can say the mass number is the sum number of protons and the neutrons in the nucleus of an atom. That is the difference between the mass number and the atomic number. Another important thing that we need to realize is that the number of protons and the number of electrons in an atom are said to be equal or are always equal, and therefore atoms are electrically neutral. So we can say that the number of protons and electrons in an atom are equal, hence we can say atoms are said to be electrically neutral. The next thing we are going to look at is the representation of an element or this atom. Representation of an atom. Representation of an atom of an element, and in this case we can say if an atom is represented by letter X, an atom should be represented by both the atomic number and the mass number, and assuming we have A and B, this A here represents the mass number of this element X, and B represents the atomic number of the same element X. Bearing in mind that mass number is the sum number of protons and neutrons in an atom, while the atomic number represented by B represents the number of protons in the nucleus of an atom. The next thing we are going to look at now, it is the arrangement of electrons in an atom, And remember, electrons occupy the energy levels in an atom. Arrangement of electrons in an atom. And we have already said that electrons occupy the space around the nucleus. Electrons occupy the space around the nucleus. Electrons occupy the space around the nucleus, and this space is made up of energy levels. This space is made up of energy levels. This space is made up of energy levels. The space is made up of energy levels, and each energy level can accommodate or hold a fixed number of electrons. Each energy level can hold a fixed number of electrons. And remember, these energy levels are numbered 1, 2, 3, starting from the one close to the nucleus. The first energy level, the first energy level takes a maximum of 2 electrons. Takes a maximum of 2 electrons. The second takes a maximum of 8 electrons, and the third energy level takes a maximum of 8 electrons. That is for the first 20 elements. For the first 20 elements. Let us look at the first 20 elements. The first 20 elements. Before we look at the electron arrangements. So the first element, which is in atomic number 1, is hydrogen. So let us have the element we have what we call the symbol of that element, and then we have the electron arrangement. So the first element is hydrogen. Hydrogen is represented by symbol H, and since it has 1 electron, the electron arrangement is only going to be 1. The number 2 is helium. The chemical symbol for helium is He, and since helium has only 2 electrons, the electron arrangement is going to be 2. Number 3, we have lithium. Lithium is in atomic number 3, and the chemical symbol for lithium is Li. The electron arrangement is going to be 2, then 1, meaning the first energy level a maximum of 2, the remaining will go to the next available energy level. Then we go to 4. which is beryllium. The chemical symbol for beryllium is Be, and since beryllium has 4 electrons, the first energy level takes a maximum of 2. Then the remaining 2 electrons move to the next energy level. Number 5, we have boron, which is represented by the chemical symbol B. And since boron has 5 electrons, the first 2 electrons occupy the first energy level. Then the remaining 3 will move to the next energy level. Then number 6 is carbon. Carbon is represented by C, capital C, with 6 electrons, and therefore the first energy level takes a maximum of 2. The remaining 4 to make them 6 goes to the next energy level, that is the second. 7 is nitrogen. Nitrogen is represented by N, and therefore the electron arrangement will be 2, 5, meaning the first energy level takes a maximum of 2. The remaining goes to the next energy level. Number 8 is oxygen. The chemical symbol of oxygen is O. The electron arrangement will be 2, 6. Next we have number 9, which is fluorine. The chemical symbol for fluorine is F. The electron arrangement will be 2, then 7. Since it is in atomic number 9, it means it has 9 electrons. The 2 electrons occupy the first energy level, while the remaining 7 goes to the second energy level. Number 10 is neon. The chemical symbol for neon is Ne, and therefore the electron arrangement is going to be 2, 8. And the second energy level takes a maximum of 2 electrons. Then number 11 is sodium. The chemical symbol for sodium is Na, which is derived from the Latin name for sodium, which is natrium. Since it has 11 electrons, the first energy level takes a maximum of 2. The second takes a maximum of 8, so 2 plus 8 is 10. So the remaining 1 electron moves to the third energy level. Number 12 is magnesium. The chemical symbol is Mg, and the electron arrangement will be 2, 8, 2. Number 13 is aluminium, with a chemical symbol of Al. The electron arrangement is going to be 2, 8, 3. We have number 14, which is silicon. The chemical symbol for silicon is Si. The electron arrangement or electron configuration will be 2, then 8. The remaining 4 electrons go to the third energy level. Number 15 is phosphorus. The chemical symbol for phosphorus is P. Since it has 15 electrons, the first 2 go to the first energy level, then the second a maximum of 8. The remaining 5 will occupy the third energy level. Number 16 is sulfur. The chemical symbol for sulfur is S, and the electron arrangement is 2, 8, 6. Number 17 is chlorine. Chlorine has a chemical symbol of Cl with an electron arrangement of 2, 8, 7. Number 18 is argon. The chemical symbol for argon is Ar, and the electron arrangement is 2, 8, 8, since it has 18 electrons. Then next we are going to have number 19, which is potassium. The chemical symbol for potassium is K, which is derived from the Latin name for potassium, which is kalium, and the electron arrangement will be 2, 8. The third one will accommodate a maximum of 8. Then the remaining 1 electron will move to the 4th energy level. And lastly, number 20, we have calcium. The chemical symbol for calcium is Ca, and the electron arrangement is going to be 2, 8, 8, 2, and that is the electron arrangement for the first 20 elements. If you look at these 20 elements, you realize that the first 2 elements have only 1 occupied energy level, and these first 2 electrons belong to period 1 of the periodic table. Then from number 3, they all have 2 occupied energy levels up to number 10, and since they have 2 occupied energy levels, these elements belong to period 2 of the periodic table. In other words, to identify the period, we look at the number of occupied energy levels. Then from sodium all the way to argon, you can see they all have 3 occupied energy levels, and elements with 3 occupied energy levels belong to period 3. Then the last 2, that is potassium and calcium, they have each 4 occupied energy levels, and in this case these elements are found in period 4 of the periodic table. Thank you for watching, and welcome to the channel.